Okay, so gonna have to do a voiceover for this recording. My battery went dead on the mic. So we're using the Tresca criterion here. So I'm looking for two stress components. I want to find I'm looking for like the 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 biggest and the smallest stress components represented by sigma 1 and sigma 2, and we're going to set that to be a yielding stress in the orthogonal direction to those two components. Now the problem is that my current question here has got a mixture of stress going off down in the x direction, and we've got some sort of shear stress term. There's 60 term. So what I want to do is, in this, actually it's going to be the xz plane, but I use this equation here, so my y becomes my temporary z using this equation. In this plane I want to work out two stress components. I'm not particularly bothered of their orientation or where they're pointing, but they're going to be in that plane, and they're going to be represented by a two pure stress terms. Okay, so let's take that equation, and we will find out how we can change this current stress rate, which is using a sort of a direct stress kind of term and a shearing stress term. So how can we replace this by two sort of orthogonal stress terms? So we're going to take our terms that we got in this plane, plug them in. So we're saying that sigma z, so that'd be your sigma y in that equation, is going to be set to 0. So you'll have 90 divided by 2. That's your sigma x. That's your 90, and we're going to add on 0 and then divide it by 2. When you stick your bracket in there, you notice you'll end up with 45, which you need to square, and then you got your shearing stress term, which is your 60, which you're going to square as well. So put that into your calculator, and you find out that the square root component comes to 75. So my shear my stress can be represented by two components. The largest one is going to be the 45 plus 75, which is 120, and the smallest one is going to be represented by the 45 take away 75. So all I've done at the moment is work out what those two, how that plane, that stress state, can be really represented by these two stress terms. Now I'm going to come to the Tresca criterion. Now this Tresca criterion, is usually we could express this actually using the shearing stress. So here we've got the yield stress in the sort of orthogonal direction, and the shearing stress is two times the maximum shearing stress that can be applied. So let's write out our equation, show you what I mean by that, and I'm going to replace this direct shear stress in the y component by the shearing stress term. So it's twice the shearing stress, and that's what we're referring to there. So we've been told what the maximum shear stress is. Okay, so in textbooks you'll normally see this written as the one stress component take away another stress component divided by 2, and that will equal the shear stress. Normally I'm just looking in Beard here, and they use subscript A and subscript B. So what I want to do is not confuse myself with the greater than or less than sign. And so what I'll do is I'll replace that, because I'm dealing with a modulus, so I'll replace the greater than or less than sign with an equals, and I'll consider where I'm trying to find the line. So I'll take my first sigma and I'll let that represent the maximum stress, and then I'm going to be taking away the other stress component, and this other stress component we're imagining is going to be pointing off into the y direction, and we'll be using the maximum shearing stress that we're allowed to apply is going to be the 80, so that's going to be 2 times 80. So I'll take that to be the first possible case, and the other case which will be based upon when things become negative. So we will say let's use the negative one. Now obviously the negative one is we will want to try to make positive, so we're going to put that in the minus sigma 2 part of the component there. So now I'm going to say that the y component, the shear going off in this y component, is going to be the bit on the left. Take away the smallest stress that I previously calculated, which will give me a positive number, and I'll set that to equal to be the maximum 2 shearing stress. So now it's a question of substituting my numbers in, rearranging this, and we're going to find the possible solutions that we're going to have for the two values for sigma y. So here I am, I'm rearranging the equations, and I'm going to look for these two possible solutions. So let's do our first equation. We'll put the 120 in, take away 2 times the 80, and that will give us our first stress term in the y direction. So that gives us a minus 40. Now let's look at the other stress term. So here we've got minus 30 going in, plus 2 times 80. You might find it easier to think about this using the Mohr circle and using the stress criterion derivative. And that gives 130, so we can see that the answer is going to be C.